Okay, this is chemistry, term 1, week 8. Uh, Basically, it's the same as last week. Acids, bases, metallic oxides, amphoteric, all this, yep. With the addition, if my STP wants to load today, chapter 3.3, which is essentially salt, pepper. It doesn't want to load, thank you. Salt preparation. Yeah, where is it? Come. Okay. Ya Allah. Okay. Yeah, so basically, same as last week, with the addition of salt preparation and 3.5.4. What is 3.8? Yeah, so basically it's just titration. Uh, so yeah, that's part of salt preparation. These are all under salt preparation, electrolytes, methods of preparing salt. Shukaman and 3.2. Acids, bases. Okay, we did all of this from last week. But see 3.3 الجديدة. Salt preparation. It's in the notes. I'm gonna try and sum it up as fast as I can. Obviously, I will have to refer to the notes for some parts because I don't. There are some things I just can't sum up. So, let me open the open board. Yalla. So, a salt, for example, NaCl, KCl, Mg2Cl, MgCl2 قصدي. Generally, a salt is made up of a cation and an anion, right? Okay. Obviously, a cation is any positive ion, except obviously H plus ions, because you can't have HCl isn't a salt, guys. It's an acid. An anion obviously is any negatively charged ion, except for OH minus, for obvious reasons, because these are for acids and bases. Okay, so they can also be grouped into soluble and insoluble. The insoluble salts are made through precipitation reactions. The soluble reactions are done through the excess method and titration. Okay, so this is a general overview. Now, I'm gonna focus on these two arrows that I just drew now. Okay, so I'm gonna draw a new diagram for salts. To prepare salts, we either prepare a soluble or insoluble. So either soluble or insoluble, right? Because sometimes you're going to get a salt that doesn't dissolve in water, it just stays floating. Or sometimes you're going to get a salt that actually dissolves in water and mixes, right? So I'm going to start first with insoluble because it's very easy. Insoluble, to get an insoluble salt, you only have one method, and it's called the precipitation method. Okay? The precipitation method is basically mixing two salts to get an insoluble salt. For example, if you remember when you add AgNO3, it's an aqueous solution, Ag plus NO3 minus. Plus, let's say مثلا NaCl, you get AgCl. And then obviously I don't care, any NO3, I don't care about this. But what I'm focusing, even though this is asked, I think, what I care about here is the AgCl. The AgCl is the important part. Because this AgCl, you know AgCl is a white precipitate that doesn't dissolve, right? So this is an example of a precipitation reaction. When you mix two ions to get two aqueous compounds together to form an insoluble salt. Soluble, two methods. First one, titration, which is new. I mean, unless you're lost in class, this is going to be the first time you hear it. And the other one, which is the excess method. Let me make this very easy for you. How they ask the question, they tell you we want to prepare, for example, NaCl. You're going to ask yourself, is NaCl soluble or insoluble? We know it has Na, which is part of the big five, so of course it's soluble. Then they're going to say, using something. Okay, let's say they said using NaOH. Okay, this is the part that's very important. Titration is when the base is soluble. Just an overview, by the way, all these soluble methods involves reacting an acid plus a base. Okay, you can react an acid with a base through titration or through the excess method. Now, for the same example I gave now, to prepare NaCl, they say, مثلا, to prepare NaCl through NaOH, what method are you going to use? NaOH is a base. Is it soluble? Has Na, so أكيد it's soluble. So what method I'm going to use? Titration. That's how they ask the questions. The excess method. The excess method involves reacting an acid with a base, right? But there are four different types of bases. You can either react the acid with a metal, react the acid with a metal oxide, react an acid with a metal hydroxide, react the acid with a metal carbonate. These four reactions I'm going to sum up very quickly. Okay, the first one. Let me go back to my acid reactions. Now, these are the four most important ones, but I have 7 written with me right now. So I'm obviously going to give you the 4 and then the last 3, which are a bit, they're important. They're in the notes. You need to know them. But it's these 4 that they ask all the time. Actually, acid plus metal. An acid plus a metal will get you the salt plus hydrogen gas. Okay, you need to memorize this. I'm telling you, I have a nice trick. All of these reactions will get you salt plus water. All of them will get you salt plus water, except let me erase this properly. Except for the one where it's just with metal, because the metal doesn't have any oxygen to make this H2 into water, right? Because H2O is water. You need an oxygen. So I memorized, you always get salt and water in these acid-base reactions, except for the one where you're adding a metal, because there's no oxygen to make it H2O. Okay, the next reaction is acid plus metal oxide. I'll just write MO. Okay, and that is, you get salt and water. نفس الشيء for the acid plus MOH, metal hydroxide. You're gonna get salt as well plus water. The fourth reaction with carbonate, acid plus MCO3, gets you also salt plus water, but now you have something extra. That extra thing, we actually studied this reaction in chapter 2 in the periodic game. You get carbon dioxide. How do I think of it? Okay, MCO3. What did you add to get from MO to MCO3? CO2, right? You added 1 carbon and you added 2 oxygens to get CO3. So that's how I memorized it. I said, oh, it's just the same as MO, but I just added a CO2. So these 4 are the most important. You can also have an acid plus M instead of CO3, SO3. And it's the same exact reaction, but instead of CS. So salt plus water plus SO2. The last, now 6 and 7 are a bit irrelevant, but they're still written, so you need to know them. A metal sulfite, okay, will get you the salt, but again, you're gonna get H2, but since you have S instead of O now, it's gonna be H2S, right? Same thing, okay? And then the last one, this one's the unique one. It's ammonium, salt, plus a base gets you a salt plus ammonia plus water. Because the ammonium salt, مثلا NH4Cl, I'll give an example for number 7 because it's kind of tricky. NH4Cl plus the base, let's say NaOH, gets you the salt, which is NaCl in this case. You just mix you box up these two. This is going to be very useful by the boxing up technique. NaCl plus ammonia gas plus water. Okay, this is just an example. This is the only tricky one in my opinion. Okay, but just memorize. Anyway, هيك شرحنا بسرعة salt preparation, the methods. This is the easiest way for the methods. As we solve questions, I'll explain as we go. Let me see if there's anything else. Titration. Okay. I'm gonna go through the steps here, okay? Titration is the progressive addition of a base to an acid or vice versa. Usually it's a base, okay? So you have this conical flask over here, and you start dripping slowly. Basically, what happens in titration is we're trying to form a salt, as we said, but the thing is here is you want to know, okay, because the salt is going to be soluble, right? We're pairing a soluble salt using this method. So how would you know that? Oh, خلاص, let me stop adding. So here's the thing: when you produce a salt, خلاص, it's like مثلا you'd have, let's say here, it's an acid, okay, and you're slowly adding base, okay, and slowly, the more base you add, the less acidic it's going to become, right? So we have a change in pH. So what we're going to do is we're going to add a few drops of indicator, let's say phenolphthalein. Phenolphthalein is usually the best one because it's colorless with an acid. So it's going to be colorless, but as you're adding base, it's going to slowly start changing color. Let me explain what happens in titration. Okay, you add base slowly and the pH begins to change. You'll see that, you can see, the color is changing. There's a certain method you have to follow for the color change thing. Okay, I have it written here in my copy book. I'm just trying to find it. Okay, we have the equivalence point. What is the equivalence point? It's called the stoichiometric point. Okay, it's basically when you're adding the titrant is this thing here. Okay, when you're adding it and then we can reaction when titrant added and stoichiometric equal to the amount of moles of substance present in okay, basically in simple terms, the equivalence point from the word equal is when the when the ratios are equal. Okay, you remember guys, a ratio was n over coefficient. Okay, so let's say مثلا, why this is important is, let's say مثلا you're adding, here we have NaOH, which is a soluble base, right? Because sodium is soluble. And here I have H2SO4. Okay? أول شيء, we're going to realize that you guys know bases have OH minus, H2SO4 have H plus. This is the basics. Any acid has H plus, any base has OH minus. When is it equivalent point? When the ratio of the OH minus, so N over coefficient for OH minus is equal to the ratio of the H plus. See, here, when you're reacting these two in the titration reaction, why am I saying this? Because this is a very important step. You have to see, here I have 2H. Here, how many do I have? 1. So that means I have to multiply the NaOH by 2. They must be equal, right? Like I'm telling you, they have to be equal. So that means you have to multiply this one by 2. So what's the coefficient of NaOH? It's actually 2, okay? So it's going to be N over, 2 of OH minus is equal to N over coefficient of H plus. What's the coefficient of H plus? It's 1. It's already, we don't have to multiply it, so it's just N H plus. It will make sense as we solve questions, but just know that equivalence point, from the word equivalence, you're adding a base OH minus, you have an acid H plus. So since it's equivalence, the ratio is equal to the ratio, okay? During a titration, the volume of the titrant is obtained by taking the difference between the last and first reading of the burette. This is a burette. For those who don't know, a burette, I was using the wrong diagram. I should be using this. For those who when you're reading a burette, you want to know how much you lost. You mark the initial point, let's say 20. Usually you take it up to 0, but sometimes you don't have enough. You take the last point, until you filled it out. هلا صارت, I don't know, وصلت لهون. How much is that? 10. Okay, at equivalence point, it says here, the number of moles of H plus equals number of moles of OH minus. Don't say it like this. Say the stoichiometric ratio. So the ratio of H plus is equal to ratio of OH minus. Okay, and then describe the preparation of sodium chloride from hydrochloric acid. This is, I'm gonna explain how, like, when you see this, I just want you to understand how the question goes, okay? They're gonna tell this, you're gonna ask a lot of these questions. They're gonna say, what do you have to add? Sodium chloride, you want to prepare NaCl from HCl. This is my acid. What base do I add? Okay, let's see. Do I have Na here? No, so that means the base should contain Na. Okay, Cl, I have it. So what else? If there's nothing else to add, you just put OH. So what do I need to add as a base? NaOH. So what method will I use for NaCl to prepare NaCl? I'm using NaOH as my base. Is that soluble? Yes, so that means you're going to use titration. So if you want to explain the method of preparation, you need to, this is preparing a titration. So you can read this if you want or whatever. One final thing I want to say, so we start the quiz. For soluble, you're going to get a solution. طب نحن we're trying to prepare. Whoa, that's such a shitty beard. Yeah. Okay. So I'm here. I'm gonna get my solution يا أخي. It's dissolved in water or whatever. So أنا بدي salt. How do you get a salt when you have a solution? You perform, it's somewhere here, to crystallize. You perform crystallization. How do you do it? You read over it very fast. This is important, by the way. I'll solve it in a second. Heat the solution in an evaporating dish directly on a flame till most of the liquid evaporates. When most of the liquid evaporates, you transfer it over a steam bath. Then you heat gently to the crystallization point. The crystallization point is checked. We can check if the solution is saturated by dipping a cold gas. Okay, yeah, this is important. If you, to see, I know I wrote this somewhere, man. Okay, anyways. If you have a hot solution, as in crystallization, you want to see if خلاص everything got crystallized. You want to see like خلاص, am I done crystallization? You dip a cold rod. The cold rod will attract the hot molecules. If you see stuff sticking to it, that means you're not done crystallization. Okay? Okay. This is just, excess method. Yeah, this is the excess method. Okay. Excess method is basically doing these reactions. Just you have an acid and you add this, you add any of these. Yeah, you can go read this if you want. They basically went through it. They used 4, I think. They used these 3 only. They skipped metal hydroxide. I think because they mean metal hydroxide is metal oxide. So these, you need to know this. You need to know this. Like, this is very important. Okay? So for the metal plus acid, you heat the acid first, okay? Put off the Bunsen burner after you heat it, then you start adding metal, okay? Why do you heat it first? Because it needs to increase the rate, because it's going to be too slow if you don't heat it, okay? How do you know if the reaction is complete? Excess metal remains, no more effervescence. You guys know acid plus metal gets you salt plus hydrogen gas. Hydrogen gas, how do you know خلاص the reaction's done? You're going to stop seeing hydrogen gas. How do you know there's hydrogen gas? There's going to be bubbling. So when you stop seeing bubbling, that's when you know it's complete. Okay, and also you're going to start seeing metal remaining at the bottom of the beaker. خلاص. Obviously, for this method, you're going to have some leftover at the bottom. So how do I get rid of that and the leftovers on this solution? I need to go take it to a filter. A filter, right? I'll put a funnel. You guys know the filter. Put a filter paper. What's going to be the residue? The residue is going to be the metal. With the filtrate is going to be the aqueous solution of the salt we just prepared. I think they wrote it here. And the filtrate is the zinc sulfate. Yeah, in this case, when you read over these are very important. Actually, no, I'll read them. Okay, acid plus metal oxide, you get salt and water. For this one, you continue heating whilst adding the metal oxide. The acid metal, you heat the acid, then you turn it off. Okay? This acid plus metal oxide, you continue heating as you're adding. So in a beaker, add a known volume, gently heat the acid throughout the experiment. And she put it in bold, italic, underline, because she's basically telling you, focus up, I'm going to get this question in the exam. Okay? Start adding spatula measures of zinc oxide to the acid and stir. Yeah, same thing as the last one, تقريبا. But this one you're just heating throughout. Continue adding the metal oxide till excess settles. filter. It's نفس الشيء. How do you know you're done here? When excess remains at the bottom of the beaker, like the one before. But why don't we have effervescence? Because there's no hydrogen gas being released, right? Acid plus metal carbonate, you don't heat, because when you have any reaction usually that has carbon dioxide, it's usually very exothermic, or it's very fast and can do a lot of splashing. For that reason, we don't heat it. Okay, so you just let it happen. So no heating. Okay, you just add. How do you know if it's complete? Same as the first one. Excess metal carbonate remains at the bottom. وما في effervescence. Why now am I saying effervescence? Because the metal carbonate will release carbon dioxide. Yeah, CO2, صح? Okay. What was this? Precipitation method. Okay, precipitation method is very easy, guys. Literally just two solutions. Solution A containing required the cation, with solution B containing the anion. They mix. Precipitate is formed that doesn't dissolve. Filter, crystallize, whatever. La. Not even crystallize, just filter and let it dry. خلاص. هيك. I think I went through everything you need for salt preparation for tomorrow. Actually, no, I skipped a question. This one, it was here بعد titration. Here. لا مش هيدي. شفت grid وقتها. يا عمي I saw it. It was grid, huh? Is it not? I don't know what it is. By the way, please, for your chemistry final, please solve all these CQDs, huh? Very, very important, guys. You will benefit. Wallah, you will benefit. Okay. I think it's just this one. I'll solve it as السريع. Okay. Here, you're adding NaOH to HCl. Okay. NaOH to HCl. You have volume concentration. You have volume concentration. Basically, when you add these two together, I want you to ask yourself, okay, it's balanced because I have 1H. Okay, that's the first thing. Okay, we can deduce, you can solve, I'll solve for you, but it's obvious you guys know N is equal to C times V, and obviously they both have the same values. So, N of NaOH is equal to N of HCl. What does that mean? The N of OH minus is equal to N of H plus. What does this mean? This is a neutral solution. In a neutral solution, we know concentration of OH minus is equal to concentration of H plus, which is equal to 10 minus 7, because the total is always 10 minus 14, right? طيب. This was not the... it's not this one. It was somewhere. CQD 28. Yes. No. Nothing. لا course chapter review 28. طب okay. طب هي مش عندي now. It's not here. طب anyway, let me stop the app. 23 minutes notes. Start chemistry. Let me submit the quiz so we can get the answers. Okay, so question 1. Which of the following can be used to prepare a soluble salt? Remember, soluble salt, we can either use titration or excess method. And titration is basically acid base. So acid base, acid with methyl. Did we say base with sulfate? No, we said acid sulfate. Hatta it wasn't even acid sulfate. I think it was actually acid metal sulfate, right? It was, let's see. Yes, sulfite, actually, not even sulfate. Metal sulfite. Anyway, this is obviously wrong. Acid, basic oxide, metal oxide, whatever, yes. Base carbonate, no, we said acid carbonate. Acid, metal carbonate. Okay, which one is not an acid? The ones that are not acids, for it to be an acid, has to release H+. Which one doesn't release H+? This one and this one. Basit, easy peasy. 26 questions. Inshallah, we'll be done at 6:49. The recording will be done by 7:15, inshallah. Which of the following can be added to sulfuric acid to prepare copper sulfate? I'm telling you, these are the questions they always ask. What can you add to sulfuric acid? H2SO4, so something plus H2SO4 to produce CuSO4, copper sulfate. Look, this is how you do it. SO4, you have it. Okay, so now we don't care. Okay. What do I have here? Cu. Do I have H2 Cu here? No, so I write Cu. Type. H2, you're not going to write H2. You never write H2. SO4. Since there's nothing else you can add here, because H2 counts as the first atom. I can't add, this is a cation. Can't add the cation. I need the anion now. What do you see? What's the anion? Look, if all the other anions are taken away, it's OH. Okay, that's how it goes. So, COH. But these also work because they want it like that. Okay, yeah. Obviously, COH is one of the answers, right? So we're gonna put it. What else? You have H2SO4 as an acid. Acid plus what will get you salt? Acid plus metal? Yes, but remember that the metals, and I gave this last week, I didn't say it this week. The metals can't be copper or silver, Cu or Ag. They can't be. Okay, but if you put copper with an oxygen, it's fine. But copper alone is unreactive. And silver. Okay, so acid. What do you add to an acid? You can add metal oxide, metal carbonate, metal hydroxide. Okay, remember they were all our cases. And I'm telling you, the three she's gonna ask, they're the ones she put in the notes, and it's these three. Over here, these three: acid metal oxide, acid metal carbonate. Okay, please be careful. Question 4. Which of the following reactions produce a pungent smelling gas that turns damp litmus blue? Okay, pungent smelling gas, NH3. Damp litmus blue, again, it's NH3. What is the only thing I gave you that will get you ammonia? It was this one here. Ammonium salt plus base, right? So ammonium salt is anything that has NH4. And the only one here that ends NH4 is this one, right? So ammonium sulfate, ammonium salt, plus base, calcium hydroxide. Anything that has OH is usually a base. Okay, actually is always a base. What is the apparatus needed for the preparation of sodium chloride by titration? What do you need for titration? Obviously, you need this conical flask over here. This is what we call a conical flask. وبدك البيرات هون صح البيرات و pipette. Why pipette? Because I need to take some drops, right? So pipette, burette, flask, conical flask. Question 6. Well, the preparation of solid salts involves solid salt. So sure. What does? Hold on. I just want to see the choices. What other choices could it be other than this? Wait, I just understood the question. What is a salt? A salt, it's an ionic compound usually, but it usually 90% of the time is a metal and the non-metal, right? Okay, and obviously it's direct. They're directly bonded to each other, like NaCl. They're directly bonded to each other. So direct metal. Let me go back to the solutions. Okay, hello. Question 7. What is a substance that dissolves in water to give ions? Of course, it's an electrolyte, guys. Because remember, it's not only preparing salts included for tomorrow, it's also last week's material. Water at 25, with the exception of chapter 2. Water at 25 degrees Celsius has what? KW is 10 minus 14. And at 25 degrees Celsius, it's usually neutral. So H equals 1 times 10 to the minus 7. Okay. OH minus ions and H plus ions are present in all aqueous solutions, right? Which ones are the acids here? This came last week in the AMS. Of course, it's HCl and HNO3. This is hydrochloric acid. This is nitric acid. This is OH is always bases. Okay. Which ones are bases? NaOH, and obviously you put NH3 to trick you. Some people they're gonna say, "Oh, bases only with OH, bro." So they won't pick NH3. Make sure you pick ammonia. It's a base. Question 12. Element X is on the left-hand side of the periodic table. The oxide of this element X is metallic and basic. This also came last week, by the way. Okay. Element X is on the left-hand side, so it's a metal. Okay. So when it's an oxide, metal oxide. Remember, metal oxides are basic. I think I can pull up Today is, oh, I can go back to November. Aha. Oh my god. Carreo. How far can I? Whoa. I gotta start deleting these, wallah. What's this like? Arnold and Richard. This is physics, grade 10. Oh my god. Like, what's this here? Hmm. Oh my days. Why am I so surprised? What is this? Chemistry grade 10? Oh my god. Anyway, today is October 15, 18, so it should be here. Whoa. No, today is October 16, so 9. Here somewhere, please, please. I don't want to write them again. Yes, okay, okay, good, good. Okay, because this is, you can need this for this quiz. Remember, memorize all of these, okay? Don't react. The neutral ones are some nonmetals like water, CO, NO, N2O. Okay? Basic ones, any of the metals, Na2O, CuO, CaO. These are colon oxides. These, by the way, they're basically the ones that we're doing for this week. So forget about the reactions for right now. Acidic, the ones that are non-metals, like CO2, it's acidic. SO2, acidic. SO3, acidic. I think they asked about CO2 last week, by the way, huh? It's CO that's neutral. CO2 is acidic, huh? P4O10 is acidic. SiO2 is acidic. And then the amphoteric ones, these are very important. Zinc oxide, PbO, Al2O3, right? Okay, so, because they ask about it in one of these questions I remember seeing. 13. Okay, bases obviously conduct electricity. They turn red paper blue, and they taste bitter. Easy. 14. Acids, they should say conducting. Yeah, they do. They turn blue paper red, and when you add zinc, when you add a metal to an acid, from our equation from this week, documents 19. We said acid plus metal is salt plus hydrogen, right? Okay. And the acids have a sour taste, but bases have bitter. 15. Okay, this one. Magnesium oxide, metal oxide, basic. CO2, carbon dioxide, non-metal oxide, acidic. COO, metal oxide, basic. N2O is neutral. N2O and NO, right? Wait, خلينا نرجع لهم. NO, yeah, N2O, NO, neutral. CO, neutral. Amphoteric, they asked this one. ZNO, amphoteric, right? SO2, acidic. Where am I? Al2O3, amphoteric. CaO, basic, because it's a metal. صح. كلهم they were written in my list. 16. A student wants to find the concentration of H plus and OH in a sample of H2A. Okay. H2A. Remember for these questions, this came by the way last week also. You dissociate it to get 2H plus and A. I don't care about the A, but I care here. Okay. That means the moles of H plus is going to be 2 times the moles of H2A because the coefficient is 2. So H2A can 0.4. Adibit here H plus 0.8. So 0.8. How do I find OH? If you always when you have H but you want OH, or you have OH but you want H, you do 10 to the minus 14 over whatever you have. Let's do it. Zero 0.8, 1.25 times 10 minus 14. Question 17. Yalla, كلها 10 questions left. I told you I'd be done inshallah by 7:15. هلا 8 minutes. No, sure, 8 minutes. 12 minutes. Calculate the concentration of H plus in 0.06 molar KOH. I think this is the one that came last week actually. KOH dissociates. Always write dissociates. K plus, since it's a base, OH minus. If you have OH, it gets you OH. Okay, 1, 1, so it's going to be the same concentration. نحن بدنا H plus. What do we have? OH. How do I find H plus? It's 10 minus 14 over 0.060. Okay, 10 whole 0.06. To 2SF, it's going to be 1.7 times 10 minus 13, right? A student asked to find the pH of a solution. He prepares an aqueous solution by dissolving 0.08 moles in 250 ml. So they gave you the moles, they gave you the volume. La 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 la. Find the concentration of H plus. What's he dissolving? Hydrochloric acid. It took me a second to find it. Hydrochloric acid is HCl. You write its dissociation, H plus and Cl minus, right? Same moles? Yes. So that means the concentration of this is equal to concentration of this. No need to multiply by anything. Anyway, how do I find concentration if you have moles and volume? C is equal to N over V. Okay. Moles 0.08. Volume 0.25. Why? Because it has to be in liters or decimeter cube, whatever you prefer to say. So 0.08 over, hold up, over, I know when, 0.08 over 0.25, you're going to get 0.32 to 3SF 0.320. Right? Okay. Deduce pH. pH is equal to minus log base 10 concentration of H plus. Right? Okay. People use just minus log H plus, which I think is the same. But I use log base 10. I honestly don't know why, but hey, my brain is convinced this is the only way to do it, so I'm just gonna do it this way. To 3 decimal places, you get 0.495. 19, the best method to obtain ZnSO4. Okay. You want to produce zinc sulfate when H2SO4 reacts with zinc oxide. Is what? Okay. You're gonna ask yourself, how do I get a solid? If you're gonna ask yourself, actually, what reaction am I doing first? Okay. أول شيء I have an acid, sulfuric acid. You should all know H2SO4. It's the most famous one. For these reactions you're gonna see tomorrow, HCl, H2SO4. These two a lot. They come a lot. Okay. H2SO4 is the acid. ZNO basic oxide because it's metallic, right? So this is the base. When reacting acid base, what are we doing? We're using the soluble method, right? We're performing soluble salts. نرجع نفرجيكم إياها. It's soluble because we're doing acid plus base. So نحن what did we tell you you need to do to obtain it? Because these will get you solutions. بس أنا بدي solid. How do I get the solid from the solution? بعمل crystallization, right? In Celli evaporation, crystallization. Very easy. على الخفيف. Okay. بس إذا كانت precipitation شو بتعمل؟ بتعمل filtration. If it was precipitation you use filtration. بس that's if it's insoluble. هلا I'm soluble because I'm reacting acid base. Question 20. A mixture of ammonium nitrate, ammonium NH4, NO3 nitrate, and NaOH solution are heated. A gas with a pungent smell is released. The gas, what's the turn litmus paper? You know, it turns damp red litmus paper to blue. Why? Because the pungent gas is what? It's NH3, it's ammonia. When you react ammonium salt with base, you get what do you get? You get ammonia. I think let me just show you. Yeah, you get salt, ammonia, water. It's just the same thing as all of them, salt and water, but since you're adding ammonium now, في شو بالموضوع في ammonia. Okay? So عندك هلا NH3. You have NH3. This gas is okay. Well, you need for part B. I didn't really see part B, but anyway, ammonia turns red litmus paper into blue. Okay, damp red litmus paper blue because it's a base. To prepare PbSO4 salt, equal quantities of what and what are mixed in water. Insoluble salts are prepared by what? PbSO4 is insoluble. If you remember our solubility rules, هلا it's what? October 16. Okay, let me go back to October 2. October 2. This is physics. Hold up. This is physics. Why was I recording physics on a Wednesday? Or maybe it is this. It's not this. كيف رجع؟ documents. يمكن هيدي. This is math. Okay. Oh, maybe. Oh, hold up. Wednesday to 25. I think it was 3 weeks ago. Oh. Oh, that's not what I want. Bro, where is it? It's. يا عمي, I wrote them before. هيدي شو؟ هيدي physics. يا الله, give me a second. Okay, so I can't find it, but I'm gonna go back to. Oh, it was in the draft. I remember. I think it was in the notes. يا الله, أنا my Wi-Fi today is it's too bad. والله, it's so bad. This one, yes. Okay. Okay. If you look here with sulfate, they're always soluble except with barium, calcium, and lead. Okay, usually lead. This is the important one. BaCaPb. Okay, these because they form white precipitates, and Pb also. Okay, so if you go here, PbSO4 is insoluble. So what method, before we read this, what method are we going to use? Precipitation. Okay, so obviously you're going to want the first one to have the cation, right? And the second one to have the anion. And these two are going to mix. You're going to get PbSO4. Okay, you get it from the choices, and you have to choose from the choices. Okay, question 22. What electrolyte dissolves exclusively? Strong. But the other one, I think you say partially. To a limited extent, yes, that would be weak. Okay, strong dissolves exclusively, weak dissolves to a certain extent. What is the reaction? Okay, yeah, this one I didn't mention it. By the way, all of these reactions are considered what we call neutralization reactions. Neutralization means acid plus base to give a neutral salt. Because when you mix acidic with basic, you get neutral, right? So these are all called acid with base. They're called neutralization reactions. During the titration of an acid with a base, the color change that occurs when. Oh, they actually asked this now. Okay. Okay, yeah. Let me go back to the notes. It was here, method. Let me read search method. Up. Yeah. You need to memorize these, okay? Always know that the phthalenes are always colorless except for with a base. Okay, phenolphthalein, I memorized it P, pink, and the other one's just blue because bases are blue. Okay, litmus, you guys know it's red when it's acidic, blue when it's basic. Methyl orange is orange when it's neutral, but it's red when it's acidic and yellow when it's basic. Okay, you can memorize these very, very easily. They're not even that hard. Okay, so obviously changing acid to base, red to yellow for methyl orange. This came as a written part in the periodic last year. Okay, know this, or not, if not last year, the year before, but one of the years. It came before in a written part. Okay, for the next periodic we're gonna have. So I'm gonna mention that when we get our periodic. I'll be solving previous year's writtens. For now, know this. You need to know this. For our last question of the day, before 7:15, what is the chemical formula? This was in the notes, this question. Substance M reacts with magnesium to get hydrogen. So it's reacting with a metal to give me hydrogen gas. It's reacting with a carbonate to get me carbon dioxide gas. And it's reacting with a metallic oxide to get me a salt. So obviously this is an acid because all of these reactions, acid plus metal carbonate, acid plus metal oxide, obviously it's an acid. So now we need to know what is this acid. The acids that we are required to know always start with H. Okay, I need to know H2. Okay, these are by default, right? They're included in every reaction with carbonate, every reaction with the metal. You're gonna get these by default. But copper, what else did I get? Chloride. So Cl. وهيك we finished before 7:15. يعطيكم ألف عافية. Good luck tomorrow. Thank you so much for watching.